Swayam Prabha, free DTH channel for education.
Now, again, what we are going to do is that this PDEs, okay, this hyperbolic PDE and parabolic PDE and elliptic PDE, we are going to transform into a standard form. Okay, that is we call as a canonical form. So in that case, what we can do is that we can study the problem very easily because the solution of the problems can be found much easily. So that is called canonical form. So in canonical form, what we are going to do is that we are going to transform the PDE. Okay, whatever PDE is given to you. For example, we are going to talk about only the, in this case, we are going to talk about only the second order linear PDE, not for the everything. We are going to talk about second order linear PDE. So in this case, how do we transform? Okay, so how do we transform to canonical form? For this, you need to introduce one more variable. Okay, two more variables or two more coordinates. We are going to transform to the coordinate eta comma n. Okay, I'm going to define a new system, new coordinate system. This is called eta equal to eta of x comma y, and chi equal to chi of x comma y, eta equal to eta of x comma y. Okay, chi and eta are two defined variables, two defined new coordinate system. So we are going to obtain the change of variable. So if you obtain the change of variable, you know, like when this is going to be bijective, this is going to be bijective means you can get the inverse of the transformation when it is possible. If there is a Jacobian, okay, Jacobian of Jacobian is nothing but dou of chi comma eta divided by dou of x comma y equal to, I can define like eta x, eta y, sorry, chi x, chi y, eta x, eta y, okay, which is not equal to 0. Then we say that this is a, if this is not equal to 0, then according to the theorems, okay, there are implicit functions here, etc. So according to those theorems, what you can say is that this is going to be bijective, means this kind of transformation is going to exist. Okay, so note that if you define chi and eta, that should be like the Jacobian should be not equal to 0. If the Jacobian is not equal to 0, then only you can define that the bijective transformation will be existed, and then you can find it. Okay. So now for this one, what we are going to do is that we are going to transform it to a new PDE, new form of means the another system which is called canonical form that we are going to classify. Okay, so if you apply that, we will see that how it is going to come. Okay, so keep remembering this one because we are going to use this kind of logic for your some of the problems which will be asked in the exams, where I will be asking you to change from one coordinate system to another coordinate system. Okay, so in this case, what we are going to have, we are going to have it is given that W of chi comma eta. Okay, I'm going to transform it to a new problem. W of chi comma eta can be written as U of x of chi comma eta, y of chi comma eta. Okay, since chi is nothing but chi of x comma y, inverse transformation is also going to exist. Therefore, that is going to be x is going to be in terms of chi comma eta I can write, and y also I can write it in chi comma eta. So here I have x comma y. Here I have chi comma eta is there. So I can find a map from here to here, okay, and I can find a map from here to here. So that is nothing but one map is, this map is nothing but chi equal to chi of x comma y, eta equal to eta of x comma y. Okay. Similarly, this map is nothing but x equal to x of chi comma eta and y equal to y of chi comma eta. Okay. So this is my W. Okay, so in this case, again, you can write like the same way. You can write U also. You can write less if it is defined. Okay, U of x comma y also you can write in the other way. U of x comma y equal to some W of eta of, okay. Okay, this around 1. Okay, let it be here. Okay, U of x comma y, let it be that. Now we are going to find the ux. Okay, ux because fine. Okay. Ux is going to become like I think there is a mistake here. One sec. There is a mistake in the typing. Okay, so this would be like W of chi comma eta is going to be U of chi of x comma y, eta of x comma y. Okay, and W of U of x comma y I can write, okay, U of x comma y, for example, U of x comma y can be written as W of x of chi comma eta and y of chi comma eta. Okay, this is going to be. Okay, so in this case, what you can find your ux. Okay, ux is going to become like, first you have to take the w eta. Okay, so for example here u of x comma y, if I want to find, then I got to take like w of eta comma w of eta. Okay, first you got to differentiate with respect to w, and w is a function of x comma y. Okay, u of x comma ux I got to find, ux is going to become like w is a function of chi comma eta, w of chi, okay, into eta is again function of x comma y, therefore this is going to become like eta x is going to come. Okay, plus again I have another variable chi is there, and again another variable is there, so I write just w eta chi eta x is going to be there. Similarly I can find uy is going to become like w chi y plus w eta y is going to be. Okay. Now uxx is going to be, you have to differentiate this one, therefore this is going to become like, first time differentiating this one, w chi into chi x whole square is going to be. Okay, because I got to differentiate again with respect to chi x, therefore it is going to become like chi x square. Then plus I have w chi, okay, and with respect to eta also I got to differentiate, therefore this is going to become like w chi eta x into chi x into eta x is going to come. Similarly, here I have one more term, okay, w chi, so I write it here, w chi into eta x, okay, xx. I got to differentiate this one with respect to again the x variable. So w chi eta w chi xx is going to come. Now same way here, so you are going to get w eta x whole square is going to come, okay, plus, and here one more time is going to come w eta chi nx eta x is going to come, okay, therefore one more time is going to come, therefore I am going to write this one as plus 2, okay, then plus one more time, here it is going to become like w eta xx is going to come. Okay, so we will have like 6 terms used to come. Okay, so I'm just flipping it into 5 terms. Okay, same way I can define the same way here. Uyy I will define it, and then I will go for uxy. So in this case, this is going to become like w wherever chi is there, wherever x is there, you replace it with y. So w chi eta chi y square plus 2 w chi eta y plus w eta y whole square plus w chi eta y plus w eta y. Now if you go for uxy, okay, uxy is going to be different. In that case, it is going to become like, first I have to differentiate this one. So w chi, okay, eta x eta y is chi x chi y is going to be there, plus, okay, then I have similarly I have w chi eta, okay, eta x eta x is going to chi x eta y is going to come, okay, chi x eta y is going to come, yeah, and then I have w chi xy is going to come. Same way here, w eta x eta y is going to come, plus I have so this one I can put it in this side, okay, and then w eta chi, okay, eta x chi y is going to come. These two are not the same, okay, therefore I am writing it separately. So 6 terms will come here. Then w eta xy is going to come. So 6 terms is going to come here. Okay. So in this case, once again you can see that, okay, if I substitute whatever values are over here, if I substitute this, then what you are going to get is, you are going to get an equation of this kind: a u chi, okay, a u chi or a w chi I can put it, okay, because I have transformed to w. So a w chi plus b w chi eta plus c w eta equal to, you are going to get pi of chi comma eta comma pi of eta comma chi comma eta comma and then I have W chi W eta and then W also. Okay, so W chi W eta. This is going to be done. So again, this is going to be a second order linear second. So this is we are starting from second order linear PD. This is also going to be a second order linear PD is going to come. So therefore, here you can see that what is A? A is going to be the collection of W chi k terms. So W chi k is appearing in all these terms. Okay, so therefore this is going to become like you can substitute it over here. So uxx, uxy, uy. So these three terms you are going to consider. So in this case, it is going to appear here. Okay, it is going to appear here. Appear here. So here I am multiplying by A, here I am multiplying by C, and here I am multiplying by B. Therefore, this is going to become like A chi x square, okay, and then plus B chi x. Sorry, here chi xy, not chi x chi y, chi xy. Okay, so chi xy plus C chi y square. Okay, this is going to be there. Then similarly, B is going to C. I will write the same way. C is going to be this term. Okay, C is going to be in terms of eta. So from wherever I have eta, that's coefficient I don't get. Okay, so in this case, this is going to become like again here keep eta. No, wait. Chi x. This was like earlier one was chi x chi y only. Here it is chi x. Okay, so chi x chi y here. Chi x chi y. Okay. Similarly, C is nothing but you are going to have A into eta x square plus B into eta x eta y plus C into eta y whole square is going to come. Same way you can define B. B is the collection of W eta term, this term. Okay, one more term is here. This term. Okay, so these terms are there. So that's why you are going to get 2 times W x eta x plus 2 times wy chi y eta y, okay, plus eta x chi x eta y and then eta x chi y. Okay, these are the terms. Okay, so here again this will be multiplied by here I have eta x, therefore this is going to become like A, and this is going to be C, okay, 2C, and then this is going to be into P. Okay, so these are all the terms of it. So now what I have, suppose this is once again kind of linear PDE. Therefore, this also we can classify as B square minus 4AC equal to 0. Okay, B square minus 4AC equal to 0. I can classify B square minus 4AC. Again, I can say like whether it is greater than 0 or less than 0 or equal to 0. I can say hyperbolic, elliptic, and then parabolic. Okay, so let us see 1 or 2 examples and then we will conclude this session. Okay, so what we are going to have is that, for example, you have, so this does not change the property. So if you calculate the B square minus 4AC, you can simplify this. What you are going to get is that you are going to get the Jacobian square into B square minus 4AC is going to come. So if B square minus 4AC is greater than 0, you are going to get small b square minus 4AC is also going to be 0. If B square minus 4AC is less than 0, again small b square minus 4AC is less than 0. So it is not going to change the transformation. The transformation is not changing the type of the P. Okay, that's what we have. So in this case, what we have, we will have a simple case, a simple problem. For example, for hyperbolic PDE, what we have is that we have B square minus 4AC is greater than 0. So simple cases like you can take A equal to 0 and C equal to 0, then automatically B square is greater than 0. So in this case, what you are going to get, you are going to have hyperbolic PDE. So if A is equal to 0 and B equal to 0, you can see that this is going to become like A into this is becoming 0 and this is becoming 0. Therefore, you are going to get W chi comma eta is going to come. W of chi comma eta equal to some pi of x comma y comma etc. is going to come. Therefore, what you are going to have, you are going to have a simple problem here. Okay, simple problem, we can solve it over here. Okay, we can transform. Suppose it is not, we are having all these questions using some transformation. You can do that. Why we are going to do that? Because if you transform it in this form, solving this problem is very easy. Okay, we will see that in the next in the afternoon session. We will see it because there are some tutorial problems. We will see it. So in this case, it is easy to solve. Okay. Again, same case. Suppose B equal to 0 and A equal to minus C. Then this is going to become like 4AC square. Therefore, this is again greater than 0. In that case also you will get that. So in that case, the problem is going to become like, you can put like this is going to vanish. So you are going to get something like A alpha W chi minus W eta is going to come, okay, into something is going to come, or simply the other some of the textbook they put W of alpha, W of beta. Okay, the alpha and beta they used to determine. Now parabolic PDE, B should be 0, at least A or C should be 0. Either B should be definitely 0, either A or C should be 0, okay, for parabolic case, or B square should be 4AC. So the simple case only we are going to take. So in this case we are going to have B is equal to 0, A equal to 0, either A equal to 0 or C equal to 0. Okay. So in that case, suppose B equal to 0 and A equal to 0, then you are going to get W eta is going to come. B equal to 0 and A equal to, sorry, B equal to 0 and A equal to 0, then W eta. B equal to 0 and C equal to 0, then you are going to get W chi is going to come. Okay. Now elliptic PDE, what you are going to have? You take B equal to 0 and A equal to C. Then this is going to become less than 0. So in this case, you are going to have B is 0, W chi, W eta is 0. So these are the canonical form of it. Okay, so you'll see the remaining things in the afternoon. We'll see some of the simple problems, and then the next class we'll solve the first order linear PDEs with the transport equation, and then we'll solve the variable separable methods for the other cases. Okay. Okay. Any questions? These are all the simple problems we are going to solve for PDE. This is in tutorial 6. Okay, some of the problems are in tutorial 6. So those things we are going to solve now. So tutorial 5 is done. So most of the problems I have solved in the class itself. Okay, so only few problems are there. I will go for the tutorial 6. We are going to go for. So I'm going to give a simple idea of what we are going to solve. Okay. So for example, so some of the problems are not in tutorial, but I'm going to still explain you that, because you are going to get the building blocks from here, basic building blocks from here. So if dy by dx equal to 0, we know the solution of this one. This is going to be like y equal to constant is going to come, right? Dy by dx equal to 0, y equal to constant is going to come in case of ODE problem. Okay. Now we are going to use this to solve the problems in PDE. So in PDE, suppose it is given ux equal to 0. Then what is u is going to become? Okay, suppose u is a function of two variables. For example, let's say u is a function of two variables. So only two variables I'm going to take. U is a function of two variables. Then what is u is going to come? So u is going to become like some function of y. So see here, y equal to c was there. Okay, here it is going to become like function of x comma y. Function of y is going to come, because if you differentiate with respect to x, it is going to be satisfied. Okay. So in the case of ODE, it was simply constant. In case of partial differentiation, it is going to be a function of another variable is going to come, which is independent of what you have. Suppose I have u is a function of x comma y comma z. Then what u is going to become? Suppose this is given ux equal to 0. U is a function of x comma y comma z, and it is given that ux equal to 0. And what is u is going to become?
Of y comma z.
F of y comma z. Okay, so that means we are going to have more than whatever is there independent of those things without like. So if u equal to f of y comma z is going to be. So in general, if I have n variables and if I have given only ux1 equal to 0, then you can write that u equal to f of remaining variables. So that is going to be the thing, because once you differentiate that, you are going to satisfy the condition whatever is given. Okay, so the same thing I have given here. So here one more thing is that here if it's any arbitrary constant you can take. Okay, here you are taking any arbitrary constant. So here any c is any arbitrary constant. Here you can take any arbitrary function. C can f of y can be any arbitrary function of y, you can take it, but provided it should be continuous, because you are taking u is equal to fy. Therefore, u should be differentiable should be there. So at least you should require that f should be continuous, so that you will have u is tangent differentiable is quite often. Okay, so you make sure that your f dash is existing and that is continuous. Okay, f dash is existing and continuous. Whenever you require u is we require u is a continuous differential case. Okay, suppose you want u as a continuous, u belongs to C1. So most of the cases, what we are going to try is that we are going to find u belongs to C1 of omega. We are going to find. So in that case, you require at least f should be f dash must be continuous. Okay, so that you will get that. Otherwise, you will not get u belongs to C1 of omega. Okay. But in general, you can relax that, because there are something. If you go for the finite element method and all, so there you will talk about the weak solutions, etc. So in that case, maybe you will not require u belongs to C1 of omega. So probably you require a locally integrable. So weak solution or weak derivatives you can define. So in that case, the Sobolev spaces and other things will come to the picture. So there you may not require this condition. You can relax that. Okay, so those are the possibilities. Okay. So again, one more problem. So again, problem only we are going to solve mostly. So uy equal to 2x. Okay. So how do we solve this problem? Okay. Uy equal to 2x. So in this case, what I need to do, I have to integrate. Okay, this is with respect to y only. I have to integrate with respect to y. Therefore, this is going to become like u, and this is going to become like 2xy is going to come. Okay, because with respect to y, this is constant. Okay, so this is something like, because something like y equal to some k is y dash equal to k is that, and y is going to become like ky is going kx is going to come, right? Y dash equal to k means y equal to kx is going to come, plus some more constant, let's say c is going to come. So same way here, uy equal to 2x means u equal to, this is with respect to y, this is constant. Okay, therefore you are going to get du by, so this I can treat it as du by dy, something similar to that. Okay, not exactly, but I'm just treating it as du by dy equal to 2x. Since there is no x involved, y involved over here, this is I can take it as k. Okay, so therefore this is equal to du by dy equal to k. So in that case, u is equal to k, y is going to come. Okay, here my integration with respect to y plus some constant is going to come. Let's say c is going to come. Okay, so in the case of ordinary differential case, it is going to become c. Whereas here, what it is going to come, u equal to 2xy is there. So if I put any function which is independent of y, I am going to get. So now if you differentiate, you are going to get this one. Uy is going to become like 2x because I have to differentiate with respect to y, and this is going to become 0. Okay, this is the case you are going to get for the. Now next one, can you say someone can? Okay, already I have given answer, so we will just tell. So next problem, uy equal to sin x. Uy equal to sin x plus cos y. Okay, how do we solve this problem? So again, same kind of thing. Okay, u of x comma y. So uy, right? Yeah, uy is given. So if you find u, that is the answer you are going to get. That we need to check. Okay. So how do we? So I have given the answer already. You can just tell me how to proceed. How do I get that answer only? Can tell. So y sin x is there plus cos y sin x, and then sin y. The minus sign will come. Okay, plus f of x is there. So ux uy, right? Yeah. Yeah. Tell me, how do I get? So here we are going to integrate with respect to y. Therefore, sin x is treated as constant. Therefore, we are going to get, this is constant. So I got to get y sin x. Okay, because this is like a k, I can treat it. This is a constant. So y sin x is going to come. Then here cos y is there. So if you integrate cos y, okay, this is something like we have you can treat this function as dy by dx equal to sin x plus some k. So in this case, you can easily find the answer. Y is going to be minus cos cos x here. Okay, cos x is there because I'm going to have this one. Cos x plus k is there. Therefore, what is y? Integral y is going to become like
Sin x.
So this is going to be minus sin x plus k is going to come, right? So sin x plus cos x, so we are going to use that. So this is the way you will get u is equal to y sin x plus cos y. Okay. Okay, here plus 1, not minus. So this is going to become like u is going to become like plus sin y plus you are going to get something. Okay, because I'm just integrating, sin y is going to be, if I differentiate, I'm going to get cos y. Sin y differentiation is going to become cos y. So u is equal to y sin x plus sin y is going to come. So here I'm going to get some constant is going to come. Therefore, that is going to become like, I can put some, it is okay, this is another problem. Suppose you have a multiple uxx z is there. How do you proceed? Uxx z equal to x plus y minus z. So we will remove one by one. So first I'm going to remove z. Therefore, I have to integrate this with respect to z. Okay, therefore this is going to become like uxx is going to become like, with respect to z, if I integrate, this is going to become like, this is with respect to z, which is constant. Therefore, it is going to become z as x z. This is again constant. Therefore, y z and this is going to become like z square by 2 plus I got to have one more variable is going to come, one more arbitrary function is going to come. That arbitrary function I'm going to call it as f of x comma y because I'm integrating with respect to z. So if you go back, you will get that. Okay, differentiate with respect to z, we are going to get x plus y minus z, and this is going to vanish. Now again, 2 integration with respect to x. Therefore, you are going to get x square by 2 into z plus xyz minus xz square by 2. Okay, xz square by 2. Okay, plus this is going to become like f of x comma y into z you are having f of x comma y. Okay, therefore you are going to have different function. This also I got to integrate. Okay, after integration, I'm going to get one more function that I call as f1 of x comma y. I don't know what is it going to come because I don't know what is f of x comma y. So you are going to get another function which is f1 of x comma y. Then I am integrating with respect to x. Therefore, one more function should come. That is going to become a g of y comma z is going to come. So here f1 is nothing but integral of f of x comma y with respect to the variable dx. Okay, with respect to the variable x. Okay. Now u again u. So this is going to become like x cubed by 6z. Okay, plus x square by 2 yz minus x square z square by 4. Again I got to do, so I'm going to have another function. So this is going to become like f2 of x comma y. So this is nothing but again the same thing. F2 is nothing but integral of f1 of x comma y. Plus here this is going to become like g of y comma z is there. So I got to integrate that. Therefore we are going to get that is nothing but this is going to become like x into g of y comma z. Plus I have one more thing, catch of y comma z. So these one things are coming. Okay. So here f2 is an arbitrary function, g is another arbitrary function, and catch is also arbitrary function. So these many things are going. Therefore, it is once you find this one, it is little difficult for you to solve the problem because you need to eliminate all these things. Because in this case, you are getting a family of curves. Here you are going to have family of surfaces are going. Okay, many families of surfaces are going. Now once again we will come for one more problem. Okay, so this is this problem what I have. So what I have dy by dx plus py, dy by dx plus py equal to q. Then we know how to solve this problem. So y equal to e power minus p dx integral e power p dx into q into dx plus some constant is going to come. Okay, this is what we have seen. Now the similar kind of thing, suppose you come for here. Okay, ux plus 2u equal to ux plus 2u equal to y is there. Okay, in this case how we solve. Almost similar kind of setup you are going to do. What you are going to do is that here almost similar to this one. Okay, here in the place of y you have u. In the place of here instead of y I have u, and q is nothing but y. Okay, so we have almost similar kind of setup is going to come here. So what we are going to do, we are going to solve this problem. So in this case, what it is going to come? So this is going to become like u is equal to. So in this case, u is equal to e power minus p dx. Okay, again integral e power p dx into y into q. Okay, q is going to be there. Okay. So here q is nothing but y for me. So I'm going to put that. Okay, so let us put that. Plus some constant is going to come here. So in this case, you are differentiating. You are having x as a variable. Therefore, here I'm going to put y. Okay. So if it is of the form ux, so if this equation is of the form ux plus pu equal to q. Okay, q of y. Okay, and p of y. Then you can p of x also you can put. Okay, p into ux you can put that, and q of x also you can put. So in that case you are going to do. Okay, either even you can put this one ux plus p of x comma y u equal to q of x comma y you can put it. Okay, you can get the answer. So here p is nothing but 2. Here p is nothing but 2. Okay, and q is nothing but y. Therefore, you are going to have u is equal to e power minus 2 dx e power 2 dx integral, and q is y plus f of y is going to come. Therefore, you are going to get e power minus 2x and then integral y into e power 2x is going to come. Okay, so y into e power 2x into dx plus f of y is going to come. That is e power minus 2x y into e power 2x by 2 plus f of y is going to come. Okay, so this is my solution. So or I can write it as y by 2 plus e power minus 2x into f of y. You can verify that it is going to satisfy that equation. Okay, probably you can verify that also. So if I just differentiate with respect to x, this one, and I'm going to get ux is going to become like, I'm going to have minus 2 e power minus 2x into f of y is going to come. Okay, so which is nothing but if I just take y u here, okay, this is u, and then if you multiply 2, this is going to become like 2 gets cancelled, y is going to come, and then this is going to become like 2. So if I sum it up, this is going to get cancelled. So I are going to put y. Okay, you can verify that. So next problem, this is u y y plus u equal to 0. Okay, so in this case, what we are going to do, we are going to do something similar to what we did in our case of the second order ODE. In second order ODE, we have solved a similar kind of problem. So the same kind of setup we are going to see. So here, u y y plus u equal to 0. So this is equivalent to y double dash plus y equal to 0. Okay, so for this problem, we know the solution. Y equal to, you are going to get, so in this case, you are going to get m square plus 1 is going to come. So m equal to plus or minus I is going to come. So your solution is going to become like a cos x plus b sin x is going to come. Okay, so in this case, you are not going to get a and b as constant. Okay, instead, what you are going to get is that a and b are going to become a function of x and x is going to come. Okay, so in the case of here u y y is there. So in this case, what I am going to write, so here instead of x, this is going to become like u is going to become like a cos y, because I am integrating with respect to y. Okay, similarly here I am having b of sin y is going to come. So only this a and b I have to write. A and b can be written as a of x into cos y plus b of x into sin y. Okay, because I have to get some constants over here. This constant I can put ax and bx. Okay, because I don't I'm integrating with respect to y only. So I can verify that uy is going to become like a of x into minus sin y is going to come. Okay, plus b of x into cos y is going to come. Similarly, you can verify that uy is going to become like minus a of x into cos y minus b of x into sin y. So you can see that if I sum this, it is going to come. Okay, so therefore it is satisfied. So here I have given f of x and g of x, but here I have given a of x and g of x. These are arbitrary functions. Okay, arbitrary functions. Now next problem. So this is something similar to that. Okay, this is u square uy equal to y. So this is similar to the separable ODE. Okay, you can treat it as a separable ODE, and then you can solve it. Or this is something similar to this equation, something similar to y square y dash equal to x. Okay, y square y dash equal to x problem. So in this case, you can solve this problem easily. Okay, using separable ODE, you can solve that. So this is going to become like y square dy equal to dx is going to come, and then you can integrate. This is going to become like y cube by 3 equal to x plus c is going to come. Okay, so equivalently here you are going to get u cube by 3 equal to, with respect to y, I am going to have y plus the, okay, so y cube by 3 is going to come. Oh, sorry, there's a mistake here.
So to x dx, x dx, x dx.
X square, x square,
Square
y square. So u is going to become like 3 by 2 into cube root I can put. Okay, 3 by 2 y square by 2 plus f of x I can put here. Okay, and then cube root. Okay, same kind of things you can do. Some constant you are going to get. This 3 by 2 I can put inside that. Either you put 3 by 2 here, or inside that you can put like as a matter you are going to get some constant arbitrary constant you are going to get. Okay, next problem. Okay, so these are some of the easy problems which you can do. For example, ax equal to sin x plus cos y. In this case, I am giving u is a function of x comma y comma z, not x comma y. Previously, I have solved this problem for x comma y already. Okay, this problem I have solved for x comma y. This is a function of x comma y. Now, a similar problem I am giving but this time I'm giving it for x comma y comma z. Therefore, your arbitrary functions will be involving y and z will be there. Okay, y and z or x and z will be there. So you have to check that. Similarly, you can solve the second problem, third problem, fourth problem, etc. Okay. Similar kind of things. Whatever I have explained here, same. Okay. Now, a few more things. I will just complete. So now what we have these three equations. We have heat equation UTT equal to, so this wave equation, okay, c square uxx, okay, and then heat equation ut is equal to alpha square uxx, and then I have Laplace equation uxx plus uyy equal to 0, and I have one more equation uxx plus uyy equal to f. I can put, that is nothing but the Poisson equation. If I put f here, that is Poisson equation. If f equal to 0, that is Laplace equation. Now what we are going to see, whether this equation u equal to x square plus t square is satisfying this wave equation or not. That we will check. Okay. So in this case, I am going to take alpha equal to 1. Okay, then we are going to see. So e equal to x square plus t square. Sorry, wave equation, right? This is wave equation here. So therefore, ut is going to become like 2t, and tt is going to become like 2, and ux is going to become like 2x, and uxx is going to become like 2. Therefore, utt is equal to uxx in this case. Okay, utt and uxx are same. Therefore, this is satisfying the wave equation. Okay, in one dimensional case. Now, second one. So this one also, whether it satisfies or not, let's see. Okay, whether again this is wave equation. So u equal to cos 4t sin 2x. So let us verify that. So ux is going to become like cos 4t cos 2x, and uxx is going to become like 4 cos 4t minus 4 cos 4t sin 2x. Okay, and ut is going to become like 4 cos 4 sin minus 4 sin 4t sin 2x, and utt is going to become like minus 16 sin 4t, sorry, cos 4t sin 2x. Therefore, here you can see that this is going to satisfy this wave equation. Utt is equal to, okay, so if I write this one, minus 16 cos 4t equal to sin 2x equal to minus 4 cos 4t sin 2x. Therefore, this is going to satisfy this equation 2 square uxx, or no, not 2 square, 1 by 2 square. Okay, correct, 1 by 2 square. Okay, because this is nothing but, if I write this one, this is going to become like minus 16 cos 4t, okay, 16 cos 4t into sin 2x equal to minus 4 cos 4t sin 2x is going to come. So cos 40 cancel, this is cancelled. Therefore, this is going to become like minus 1 by 4 is going to come. Okay, therefore utt is equal to 1 by 2 square ux is going to come. Okay, this is going to be satisfied. So this is satisfying this wave equation. Okay, this is satisfying the wave equation where alpha c square, c is nothing but 2. 1 by 2, c is nothing but 1 by 2. Next problem again. This is whether we will see whether this is satisfying heat equation. So e equal to e power minus t sin x. Okay. So once we derive that solution, we can see that this is we are going to get our equation in this format only. One of this format in this point. That's what we are going to see in the next class. Okay. So we'll see that e power minus t. So ut is going to become like minus e power minus t sin x. X is going to become like e power minus t cos x, and uxx is going to become like e power minus t minus sin x is going to come. Therefore, uxx is equal to utt. So ut is equal to uxx is equal to. Okay, so that is satisfied. Next problem. Okay, a similar kind of thing. So instead of omega, instead of this one, I am having e power minus omega square c square t cos omega t is there. So I have to check that whether it is going to satisfy. So this is going to satisfy the c square uxx. Okay, not ut equal to xx, but c square uxx is going to satisfy. So you can see that ut is going to become like minus omega square c square e power minus omega square c square t into cos omega t, and ux you are going to get like omega square minus omega square sin omega t is going to come, and uxx is going to become like minus omega here minus omega square cos omega t into this is the e power minus c square omega t. T is there. Here also e power c square omega square t is there. So therefore you can see that this is nothing but ut is nothing but what is going to come? It is going to become like, okay. So if I multiply here,
excuse me, sir.
I think there is a small mistake I made at somewhere. But yeah, tell me.
Excuse me,
So
sir.
here I make small. Yeah, tell me.
Sir,
Here
could
I
you
make
kindly
small.
write a little bigger, sir? It is not visible, sir.
Okay.
Sir, you took cos
Here-
omega t, sir. It is cos omega s x.
Okay, sorry. Yeah. So this one, so here is it, up to here it was okay, right? So here we have ut is equal to minus 16 cos t sin 2x is there. So here if I multiply by minus 4, okay, so if I multiply by 4, this is going to become like the same thing. Therefore, I can write this as 2 square xx's. Earlier I said it is not 1 by 2 square, it should be 2 square, because here I got to multiply by 4, then only it is going to become like uxx. Okay, ut is equal to 2 square uxx. Therefore, here c is nothing but 2, okay, not 1 by 2. That is a mistake I made. Okay, so remember that. Now, if you go for this one, is it visible now? E power minus omega square c square t into cos omega x. Okay, so ut is going to be minus omega square c square e power minus omega square c square t cos omega x is going to come. Ux is going to become like minus e power minus is going to come, okay, minus omega into e power minus omega square c square t sin omega x is going to come. Uxx is going to become like minus omega square e power minus omega square c square t cos omega x is going to come. So if these two satisfied, then this is ut is going to become like, if I multiply this one by c square, then this is going to happen. Okay, c square omega xx. Sorry, uxx. Ut is equal to c square uxx. Okay, so this is going to. Fine. Next one. Okay, we got to check whether this is satisfying the Laplace equation. Okay, let us verify. So what you have u equal to e power x cos y. So ux first you got to find, that is e power x cos y. Uxx is also e power x cos y. Okay, and uy is going to become like e power x minus e power x sin y, and uyy is going to become like minus e power x cos y. So you sum these together, therefore you are going to get uxx plus uyy equal to 0. Therefore it is satisfying the Laplace equation. Next problem. Okay. So tan inverse of y by x. So u is equal to tan inverse of y by x. You have to check whether it is satisfying or not. So what is ux? What is ux for tan inverse? Anyone? What is tan inverse?
1 upon 1 by x square.
1 upon 1 by x square is going to come. So here y square by x square is going to come into, I got differential with respect to x, therefore I got to have minus 1 by x square, right? I got differential with respect to x also, therefore I'm going to get minus y by x square is going to come, because y is constant there, so you're going to get minus y by x square. With respect to y, you don't have anything, so it is not going to come. Now what is y? So this I can simplify. So this is going to become like 1 by x square plus y square into x square divided by minus y by x square is going to come. So x square cancels. So you are going to get minus y by x square plus y square. What is uxx? What is uxx? You can tell me the answer. Similarly, we find uy also. So uy is going to become like 1 by 1 plus y square by x square into with respect to y only you got to differentiate, therefore it is going to become like 1 by x only. So this is going to become like again same thing. So x square plus x square is going to come in the numerator and x cancel, so it is going to become like x by x square plus y square is going to come. So now what is uyy and uxx you got to find. Okay, uxx, what is uxx? You need to verify that this is satisfying or not. I think this is the last problem. Okay, no problem. What is uxx? So you got to find this one once again. Okay, so you got to differentiate. Therefore, this is going to become like x square plus y square the whole square. Okay, and then if I differentiate VDU formula, so VDU minus UVDU output. So you are going to get x square plus y square. Okay, into u, that is 0. Okay, u dash equal to that is 0 because it is respect to y, minus you are going to have y into, okay, this one I got to differentiate, therefore it is going to connect to x. So minus into minus plus is going to come. Okay, plus y into x. Now here once again I got to do the same thing. So this is going to become like x square plus y square into 0 because x is in that, and then here if I differentiate, this is going to become like minus 2yx, okay, divided by, because y square if I differentiate, that is going to become 2y, and then x square plus y square is going to become whole square. So that is going to become like 2yx divided by x square plus y square the whole square, and this is going to become like minus 2yx divided by x square plus y square the whole square is going to come. So if I sum these together, we are going to get this. This is going to be satisfied. Uxx plus y. Next problem, I think last problem. So now what you need to prove is that you need to prove that so this problem you got to prove that it satisfies a Poisson equation. Okay, u equal to y by x is satisfying the Poisson equation. Okay, so means my f is also given, f equal to 2y by x cube is given. So you go to start, you got to check whether it is. Okay, so ux is going to become like minus y by x square. Okay, and then uxx is going to become like plus 2y by x cube is going to come. Yeah, and then uy is going to become like 1 by x, and uy is this one, and uyy is going to become like 0. Okay, so now you need to check whether it is satisfying it or not. Uyy is already 0. Okay, therefore uxx is nothing but already TCF 2y by x cube. Okay, so therefore uxx plus uyy, because uyy is already 0, therefore it is going to become. Okay, so you get uxx equal to f. Okay, and uyy is already 0, therefore uxx plus uy is also going to f. Okay, so that's all for today's class. So I have completed already because I solved most of the problems. So if you have any other questions, let me know.